Continuous online.
Right, house to it.
There's this motions that are less to the right. There's a mark say really it's living the ground. It's very beautiful. So if it was to be already zero. This year it's a good portion.
Nicola,
Yes.
Valentina is connected, but she cannot hear.
No, we're not speaking.
Yeah, we are not saying anything. Maybe that's the reason. Can you hear me? Valentina, can you hear us? Valentina, can you hear us? Massimo, can you hear us?
Nicola, I am on the phone with Valentina, and we are trying to connect her. Martina, can you hear us?
Hello, good morning. Can you hear me?
Yes, we can hear you. Can you hear us?
Yes, yes.
With June.
We are ready.
Yes, you can first.
Welcome back. We have the Roundtable, the InnovaMare project. This is an integration project, and the Roundtable will cover good future and robotics and sensors, new sustainability, evolution, and economic value innovation ecosystems. We have here with us Ivan Balum from the University of Croatia, UNIZG-FER, University of Croatia, and the project manager Maritime from the Croatian Chamber of Economy, and online we will have Massimo Caccia from CNR ENM, Italy, and Fantino Matricardo from CNR Italy from Venice. And that's it.
Thank you. Does everybody hear me? Can you hear me now? So, who's a big deal? Okay, welcome everybody. Thank you very much for joining us on this square table talk. I'll give you a brief introduction about what we have meant when we started the project InnovaMare, just to understand you as audience what that project means. So today, when we look at social challenges, we see not only from perspective of environment, but we see it as an economical problem as well. And unfortunately, in the history, it showed when we have an ecological problem, it is very harder to have huge impact to solve this ecological problem. But when we come to economical problem, then the companies and all the institutions are ready to help and fix the environment problem because it became an economical problem. And now this is the case, and this is why the Euro has a Green Deal, and it invests a lot in green technologies. And this was our thought in mind when we were developing the InnovaMare project. So in the near future, definitely we are talking about 5 to 10 years, we will have definitely a huge environmental problem with sea pollution, specifically Adriatic Sea. And it will have a huge impact not only on the environment, but economical as well. We have huge sectors in Italy and Croatia as well that will have that impact, as tourism, agriculture, fishery, nautical transportation. And we think that in the near future, financing of these solutions, innovative solutions that could tackle this challenge of sea pollution will be greater. And this is the opportunity for the solution providers, I call it like that. These are the companies, universities, and others who can work on innovative solutions that could tackle this challenge, and by that get the financing from the European Union and possibility other ways of financing. And to do that, to be practical and to be methodological, we see an innovation ecosystem as a way how we can gather all the solution providers and all the sources that are for financing and combine them together. So InnovaMare project is developing innovation ecosystem in Shibani, in where we want to bring all the solution providers, that means companies, universities, local and regional community, and to develop together, to understand the main priorities of sea pollution. What are the priorities that we need to tackle? Because at the moment there's a lot of activities and projects in different scope of actions regarding sea pollution. But if you want to really tackle this challenge, you have to define the priorities and work all together in these sets of priorities. And when we define that, we have to look for the solution providers, how to develop these innovative solutions, and then look for the financing that will develop this, that will finance this development of these innovative solutions, and then put them in practice and see how this will have an impact. So this is the main idea of InnovaMare project, and we hope that you all will be in the near future part of that innovation ecosystem that will be developed in Shibani. Okay, so guys, thank you very much for joining us today on this square table discussion. Well, my first question is regarding exactly this innovation ecosystem. What would be your first associations when we talk about innovation ecosystem? What are the key elements of innovation ecosystem from your point of view, from your perspective as a scientific research institution?
There are definitely, can you hear me? There are definitely many people here in the room, and I know also online, who are capable of saying what the innovation ecosystem is for them also. But I will tell you from the perspective of the faculty, which is a member of the University of Zagreb, what we consider an innovation ecosystem to be. As you said, the triple helix formed on one side by universities, by research institutions, on the other side by public, and on the third side by the SMEs and companies. And this is something that I believe in Croatia, when we are talking about Croatian innovation ecosystem, I believe that we are missing that deeply. There are some initiatives, even from people in this room at the moment, who are trying to find their way in the market when it comes to marine robotics, and I fully support that. I do believe that we need to somehow incentivize these people to increase their efforts and to be more visible when it comes to innovation ecosystem related to marine robotics. Because in the last 10 or even 15 years, I would say that Croatia has profiled when it comes to research related to marine robotics. This has been extending recently to other universities, not only the University of Zagreb, which I believe is a very good thing, but I think that we need to invest more in developing the SMEs that will exploit usage of research results that have been developed in university environments.
Thank you. Thank you. We'll go back to Italian partners and then get back to Croatian partner. Mr. Kacha, do you hear me? Is anybody?
Just a bit.
Yes?
Yeah.
Okay. would you say that scientific research institutions are some of the enablers of innovation ecosystem, and how do you see key elements of innovation ecosystem in Italy? What are the key elements from your side?
Okay, and what I see with respect to the innovation ecosystem we are going to implement in InnovaMare project is basically the result of 13 years of cooperation with the University of Zagreb. I remember when Nicola came to us during his PhD period, and we had a long cooperation, and at this time, I think that finally there is the possibility of doing something really together. And during last years also, the technology in unmanned marine vehicles changed a bit with many improvement, and especially with respect to the fact that now we are able to build lighter, cheaper, and more modular robots. And this is quite important because it was possible also for research institutions to move from pure research robotics to innovation, to transfer of technology. And this is also seen by the kind of projects that we are implementing now, because we have now Interreg projects, EMFF projects, I mean, projects that are not purely RTD, but also transfer of technology and innovation in cooperation with end users. And the opportunity of having this ecosystem in the northeast of Italy and Croatia is very good. And what is important to say is that it is completely mature. There is not it is not forced by a project or something like that. I know that basically we are ready for doing this. And this is basically my view. Then maybe we can go deeper for other things, more details, and so on.
You just mentioned one part that is very important in all of these elements is this robotics and sensors. So when we started innovation ecosystem, we could talk about digitalization, digital innovation hub, and talk about digitalization in general. Our talk was let's put some challenge, some social challenge directly in spot of the technology. So to understand what social challenge we are trying to solve and to understand what technology we are trying to use. And this was the idea in InnovaMare project. So we defined as social challenges sea pollution, as you already told, but the technology to tackle that at the beginning, of course, it's going to be developed through the years, but at the beginning is robotics and sensors. So my next question is, what could be the main robotic and sensors attributes that could help in monitoring and prevention of sea pollution? Yeah, please.
Regarding the technology, in general, I think we are more or less ready, but it has to be, let's say, adapted to these specific problems. Of course, marine environment is not as friendly as anything on land, so it's very difficult to get, when things are not working, like when you're on the water with electronics, it gets messy. But I think this is the right moment that we can tackle these challenges and really develop systems, robotic systems and sensors that can approach these ecological challenges and solve them actually. So for example, I'm from University of Dubrovnik, as we are the south, so we are most impacted by sea pollution coming from the south. So we are now involved in two big projects that we are trying to develop new technologies to tackle these issues on the ground, seafloor, and on the surface. But the tip here is the following. So in innovation ecosystem regarding the sea pollution and these ecology as well, we need to include the local authorities as well. Because these systems are expensive, right? And ecology is expensive. So we have to coordinate with local authorities, and they have to be our end users for these systems, because just putting, let's say, 4 or 5 million worth of project system in work to tackle this issue is not trivial. So we have to coordinate with them as well. So include them in this group.
Gregory, I'd like to thank you for joining us, Mr. Gregory. Okay, now we understand, as you said at the beginning, we have 3 main pillars from my perspective on what we need to solve. So we have a problem. We have a first pillar is to understand the problem. We need to define the priorities, what we want to tackle in this sea pollution. There is a huge lot of problem, but we need to say priorities. Second pillar is financing. Who will finance these solutions at the beginning? And the answer on that from one part is this EU financing, possibility of getting EU funding. But what we need to understand that innovation ecosystem needs to bring these EU financing, but as well as local and regional government, which should be the demand-driven part. And on the third part, we have to see what are the economical benefits that we have some kind of funding from private funds or venture capital funds that could be funding these kind of solutions. And the third part is to have the solutions. You know, if we don't have solutions that could tackle the problems that we have defined, that we need to innovate, we need to make them better to do that. So at the beginning, I will first come to the first question because Mr. Gregory is his expertise is innovation. And I will ask you, what would you say that innovation ecosystem are key elements of? What are the key elements of innovation ecosystem from your point of view?
Okay. Thank you. So close interaction between, so the key elements is knowledge creation, knowledge communication, and knowledge capitalization. So it's the close interaction between the technological and research institutions in an area with the industry and all the legal and legal authorities that set up the rules for market rules for and all these issues. So close interaction between knowledge creation, knowledge capitalization, knowledge communication, knowledge technology transfer, and the industry and the legal systems. It's a key element of the establishment of a successful innovation ecosystem. Now, how you establish that? Sometimes it's a bottom-up process. That is, it so happens that all the key elements of the ecosystem happen to be nearby. In which case, it's a big incentive, a big motivation for them to collaborate and create the opportunities for innovation. Other times, you try to approach it as a top-down organization that is trying to establish to set up some frameworks for encouraging the collaboration between academic institutions, research institutions, industry, and market players, so that the outcome of that will be the increased innovation in the region. We've seen examples, let's say clusters in the Silicon Valley or something like that, the example of bottom-up, but with the key playing the role, the government playing a key role in instigating the core elements of this ecosystem by setting up the academic institutions, research institutions, facilitating the financing of that of the ecosystem through the proper legal setting that allows the investment and promotes the investment in private enterprises, and of course setting up the rules for competition, allowing the market to operate without too much intervention.
Thank you. We'll get back. I think we'll all together guide what means innovation ecosystem and who are the main stakeholders. So we have private sector, we have public sector, we have scientific research institutions, and that's mostly said in the last 10 years. A lot of times, triple helix, quadruple helix, cooperation, etc. But in practical ways, sometimes some elements need to be combined, that this makes sense, that it happens. And a lot of times in Croatia, this top-down approach is not beneficial for the development of sustainable supporting structures. They are not sustainable at the end, we saw that. So my idea was that we could have a two-way approach, top-down and bottom-up, and that's what Mr. Greger said, and I really appreciate that way. Okay, when we talk about robotics and sensors in today's perspective, what parts of robotics and sensors should be improved? Is this the hardware? Is this the software? Is this the in what parts sensors can be improved to have the best usage in monitoring information distribution?
That's a wonderful question to ask in a room full of people who are involved with robotics in one way or another.
Yeah.
And fortunately, at the European level, we have an association that's called EU-Robotics, and they closely collaborate with the European Commission when it comes to road mapping robotics research and development. Or many of us here have participated in the previous framework road mapping process. Some of us are also participating in next frameworks road mapping process. And I have to say that there is no direct answer to the question what needs to be done in robotics and sensors, because all the things can be improved. Of course, this is why we grow up doing robotics and being involved in technology, because it needs constant improvement. However, the question is which direction we would like to go, which direction we would like to take as Europe. Now I'm talking as Europe. And this is why we have these road mapping processes where we try to identify the areas where we are strong. We try to align them with specific smart specialization strategies of various countries. And in this whole complex process of bidding and auctioning what to do in robotics in Europe in the following period, we come up with a document that tells us which are the strategic areas in which we want to continue the development of robotics. And they include both mechatronics, both electronics, artificial intelligence, which is the hype now, so that's probably the first thing I should have said. And those who are involved with the artificial intelligence as is know that this is only a tool to try and accomplish something.
So would you say, let's say that when developing a robotic system or robots, there are two different elements, so mechatronics and materials, and the possibility of these kind, and software on the other hand, artificial intelligence, etc. Do you divide these two elements, or how do you divide the let's say robotic system into?
I wouldn't even dare to make such a clean cut.
Okay.
But yes. You could say that, but I don't even believe that there is a need to make this division, because now you not only have mechatronics in a classical sense, software in the classical sense, it's all intertwined. You add humans in the loop to make things just a bit more complex. Then you get some new methodologies like soft robotics, which we had the pleasure of hearing yesterday, and today. So it's all now a mush that is very difficult to differentiate. Maybe somebody disagrees, but this is my opinion.
So basically, there's an idea, not an idea, but it's a statistical saying in Croatia as well, in EU and in the world, that companies today are starting with at least 2 or more owners or founders, because the approach to the market in any businesses, it's so complicated that it's interdisciplinary approach, and they need a couple of people as founders and owners so they can be successful in the market. So we can say that as well in the developing of robotics and sensors. You need interdisciplinary team to build some robotic system.
Definitely. This is something that we can agree on.
Okay. So when we are looking from position of solution providers in, let's say, map of excellence that we are developing in InnovaMare project, we are definitely need to look through all of the value chain on developing robotics. So all the parts are necessary to be combined in this map of excellence, if you look from that perspective. Okay. Okay, the biggest part regarding the bringing the knowledge to the market is the technology transfer. FER is one of the rarest, I'm not sure if the only institution in Croatia that has successful spin-off companies on the market. And the technology transfer in that sense is very important. Can you tell us how did you came to have these spin-off companies? Did you firstly had a product or knowledge and then you look for the market, or it was other way around? What was the process of making this spin-off?
Again, I cannot generalize. I can tell a story from the experience of my way. And I'm very happy to say that the CEO of one of our spin-offs is also here with us today, so maybe he can share his opinion on this technology transfer from university to the market. I believe that what happened to us, and I cannot say that we were successful at it, I can just say that we tried. What happened with us is we did what I believe we do best, and that's research and development. And after some time, I believe that we succeeded in obtaining some nice research results, and stars aligned, something happened, and we decided that some of these things might be suitable for the market. Then some more stars aligned in the skies, and we connected with some other people who helped us in this process of commercializing products. So that's our story.
Okay, that's understandable. It has sense. Let's go back to Italian partners. Do we have Antina here with us? Antina?
Yes, hello.
Hi. I wanted to ask you a question regarding the, let's say, technology transfer, but as well some kind of a vision when we talk about marine robotics. What is the vision of marine robotics? When you tell a story of people who doesn't understand in general regarding marine robotics, what would you say is the vision? What they can do, let's say 20 years from now, what they can do, what they will be able to do.
Okay, thank you for the opportunity. In fact, I'm not an aerobatic expert, but I really enjoy to be part of this group, because I think that robotics can be really the future for many applications. And in particular, we have thought of many applications that we could do with the vehicles that we wanted to develop during the InnovaMare project. For example, we know that there are possibilities. For example, we normally do a lot of work using boats that are very expensive and require difficult programming and for example, to survey some areas, to map, to use it for to produce maps for navigations or maps to study the seafloor or to study the ecosystem on the seafloor, so the possibility of using robotics and so automatic vehicles that can collect the data and so be more efficient, save money also, because to rent the boat and etc. it's very expensive. But also I mean, the future that I see, it's really that you can release your vehicle and you can collect your data and you can somehow transfer this data to the office and collect them in a sort of automatic way. This would be really important in programs of monitoring the environment, because you could do it periodically and automatically. So automatizing sort of also the part of acquisition of data, where now we are trying to, of course, automatize the process of data, but it would be nice also to go towards this. And the applications are different. I mean, and the application is different depending on the sensor you have mounted on your vehicle. So we were thinking for InnovaMare to install different sensors. So sensor to map, as I said, the seafloor with high resolution, so to obtain information about for example, also the distribution of habitats or to other monitoring that are connected to the marine strategy in general for seafloor integrity or other things. But we also would like to install, for example, high resolution cameras, so that we could do like missions that are adaptable. So we can first map, for example, a part of the seafloor, but then if we see something interesting, then we can activate the camera and we can see also the image relative to what we are maybe mapping acoustically. So these are some of the applications. Of course, there can be others, for example, also for underwater archaeology or for I don't know, transportation, so to provide hydrographic data to harbors. I mean, there are different, or even we were thinking to also to install like a probe that could also record pollution. So in principle, if there is an accident or something where we need to collect data of for example pollution very quickly, you can just deliver your robot and collect this data, so that without any danger for the operators. So these are some of the applications that we're thinking of. Sorry for the background.
No worry, it's a normal problem in every company. So, Ivana, can you have some words regarding the vision? What we can do with robotics and servers in the next 20 years? Visual, what we can have as a vision?
As Nicola said, before, so Europe invested a lot of money in the last 10 years for developing robotics and different robotic solutions. And it paid off, because now if you see even the project that we saw today, they are very different applications, but the problem is always the same. You need to tune the sensor, you need to, let's say, do hardware like in a certain way, but the applications are getting more and more vast. So you can now use robotics from agriculture to environmental protection to archaeology or even psychology. So I think the possibilities are infinite, and the goal now is probably to sensitize the public and definitely legislation, because this combination, I mean, there's always room for improvement in the technological part, and we will be continuing working on this, definitely, because we are at universities and we are happy to do that. But this part, I think, the applications are just opening up.
Thank you. Thank you. I'll tell you my vision. When I'm a master of economy and PhD in economy, and I'm definitely not in any way expert in robotics and sensors. But when we started a project, my vision was to have 5,000 artificial fish who are swimming along the Adriatic Sea, and they get the possibilities to gather on daily basis all the elements of salinization, some elements of sea pollution, and to give us the exact data, not in a day, but in an hour, what is happening in the Adriatic Sea. This is the vision for 20 years. That was my vision in my mind. And I'm not sure that it cannot be happening for 20 years, because today when we see what the regions are doing, what the Stanford University in America is doing, have these artificial fish, and definitely they have this capability of sensoring all these elements that I just mentioned. So if we talk about this development of technology that we see in the last 10 years or 10 to 20 years, it could happen. It could happen. But from your position, you will tell me if it's possible. But I'm going in that direction just for you to know.
Can I jump in and maybe ask Stefan? Matteo said that his vision is having 2,000 artificial fish.
5,000.
5,000 artificial fish living around the sea. And immediately,
he knows about subcotron.
Immediately I thought of subcotron. So would you like to share maybe your thoughts on what we did in subcotron? I wouldn't like to be the only one talking here at Roundtable about subcotron. I would love you and your experience on how feasible it is to have 2,000 fish in the under 5,000 fish. You will now hear why I'm reducing this number all the time.
So you heard about subcotron during yesterday. I think several people mentioned subcotron. So you know that we had 3 agents, 8 fish, 8 mussels, and 8 heads. And those 8 fish actually, from the hardware point of view, they were the most difficult part of the system that we tried to build. And at the beginning, now I can say that because we got excellent marks, but at the beginning we planned for 25 fish. And actually we built, I think, 5 or 8. So it was very difficult to build those. And the other point is that even if you build them, then it's very, very difficult to make them autonomous. So we made them autonomous in small areas like 10 times 10 meters, so we could control them. But if you count on open sea, it's very, very challenging problem. And finally, many times we got the question, okay, once we have a system, what you are planning to do with the system? And we said, we referred to Venice Lagoon, we said, yeah, we will measure quality of water, etc., many very nice things there, and we did that. But it came to our mind that maybe we could somehow provide more human way to grow fish, especially, for example, tuna. So not to put them in cages, but to leave them somehow to swim to open ocean, and then have artificial fish in a school of tuna, and somehow figure out how tuna move. And then if we can provide our fish to mimic real tuna, maybe we can get those schools of tuna to come close to the, I don't know, harbor or to the ships, and then we actually collect them. In that way, we will keep collect them. Yeah. So, but in that way, we will keep, let's say, environment more sustainable, because, as you know, when we have those huge nets, below those nets, actually there is no flora, no fauna, it's really, really polluted. So this was one of the things that we were, let's say, it was far-fetched, maybe 50 years, 100 years from now, to have really herding of fish, but having artificial fish swimming together in the school. If this will happen, I don't know, probably would, but at the moment, from a technological point of view, we have very, very huge problems to make 25 fish, not 5,000.
So basically, you have the ability that fish moves artificially. Artificial fish moves through the sea and stays in the sea, but the problem is the autonomous autonomous reach, right? Because of the battery and the connection.
Not only that, but also navigation. Actually, how to figure out where this, if you would like fish to swim with artificial fish to swim with tuna, for example, you have to know where tuna is. So you need sensing devices and artificial fish that will figure out where the school of tuna is to get to the school of tuna and then swim. And so there's so many. It's not only navigation, but it's sensory.
Yeah, but this is very far-fetched for me. But the fish that only do area scoping and sensoring area, moving, let's say, 50 kilometers here and from here to then, and taking collection of data on a daily basis, we can see that for 20 years.
Really, I don't know. You should ask marine guys.
Massimo, can you tell me, is my vision possible? Can we have in 20 years 5,000 artificial fish in the Adriatic Sea collecting daily, hourly basis data on what is happening in the Adriatic Sea? Is this possible?
Okay, I cannot understand. I hear there is a very bad audio. I couldn't understand. Sorry, I couldn't follow.
Okay.
Please try again, but I'm sorry. I'm very sorry.
Do you hear me now good? Do you hear me good now?
It's difficult.
Okay. Do you hear what is my voice now? Do you hear me?
Just, yeah.
Okay. What do you think? Is it possible for 20 years to have artificial fish swimming in the Adriatic Sea and collecting data in everyday basis or hourly basis? Is this possible?
Oh, very interesting question. And what's the future? And what we have related to biomimetic robotics is a big question mark for our future, also for interdisciplinary aspects and the possibility of having a kind of revolution in marine robotics. Because what also when discussing before, when Nicola told about which are the perspectives for robotics, what there is new and so on, we have one key point that is related to new materials. And to have an artificial fish, from my point of view, it is strictly related to have new materials. Because when you need to do it from a mechanical point of view, we need probably too many joints. It is difficult to do it if we don't develop materials that can in some way have a sinusoidal motion if suitably excited by commanded voltage. But it is something that we don't have at this time. We need continuous research about that. And this also leads to new concepts in robotics and control, because we will have mechanical systems that will be probably completely different from the ones we have now. This is the big bet, I say, for our discipline in the future.
Massimo.
We could have maybe this 20 years, 30 years to have something operational.
Massimo,
yeah.
Can you hear me?
Yes, very well.
Okay, Kemal here. So question would be, instead of exploring new material, new mechanical things, would it be better to think about kind of further miniaturization so that we have kind of attachment to living fish? So living fish doing work for us instead of inventing artificial fish. So seeing a kind of accelerated rate about microelectronics, how devices are becoming extremely small, then would it be more easier or more reliable or more realistic to have something which is attached to living fish and at certain point disconnected, going up and bringing everything? What do you think?
There is something already existing about that. And of course, with further miniaturization and low consumption miniaturization of power suppliers, it would be quite possible to do something in this direction. Of course, it is something different because from to have a robot. In that case, in any case, you could have, for instance, monitoring on some variables of the ocean or in areas where the fishes goes. That is something different from saying, okay, I send the robot in a place doing something. It will be possible, but it is, from my point of view, something different. The other aspect is related to data collection and to geolocalization of the data. Of course, you will have, in that case, an approximate localization of the fish, because I think it is not so realistic to imagine a very small chip mounted on a living fish and have a nice localization of that guy. But maybe when the fish comes close to the surface or come closer to a place where there is some, let's say, acoustic beacon and transmitter, it could release, discharge some data and so on. It is something just a bit different from having an artificial fish.
I'm not sure that fish protection people would like this technology, but please, Mr. Gregory, or who wants to say something? Kemal, please. You hear us?
Sound coming from the room is very bad. And I see that other speakers are also indicating. I don't know, is it a problem with your connection for mic or whatever, but I hear much better Massimo than you in a room. So just to use this moment to thank Massimo, I appreciate your answer, since for a long time I'm kind of a fan of hybrid systems, combining artificial intelligence or field of artificial intelligence, which is currently in a hype of machine learning, with something which is hybrid thing. I'm not thinking about eventual humans being augmented, but first thing will be eventually animals and insects. And in that sense, I was planning several years ago, saying that the future architecture is a hybrid architecture, combining living and silicon things. So Massimo, thanks a lot for kind of putting your perspective on this, and I appreciate very much your comment.
And I appreciated a lot of your point of view that you explained well now. And I think it could be quite interesting for the future.
Thank you very much. Mr. Gregory, do you have a thought on that? You hear us, Mr. Gregory? Do you have a thought?
Oh, yeah. One, following up on Kemal's idea about using living fish, I'd like to ask probably Massimo, the idea of data mules. We were experimenting in the past, in info stations and info ways, since there was a limited bandwidth in dumping data from a moving object to the infrastructure, we were experimenting in wireless networks with data mules. That is, devices that would carry information from for short distances and then dumping this information to other devices to carry it along. Have ideas like these be used in this school of fish environment where some data from some artificial fish or robots are conveyed to neighboring fish, which will be further on transmitting that to a gateway that will finally deliver it to the cloud or to the infrastructure. Ideas like that have been used to marine communications.
Thank you.
Yes.
What's your thoughts on this topic?
I just want to comment on this. It's very interesting and long-term idea for augmenting living things with robotic parts. But that raises another issue of ethics. Like humans can decide whether they want to implement something or not. Like how will you impose or let's say force just take unconscious being and put something on it without raising a lot of ethical issues. So that would be it's definitely a plus. Like, we can use a lot of things that evolved for millions of years regarding localization, for example, what Stefan mentioned, which is natural for, let's say, tunas. But how will we be able to live with ourselves after? Like, let's say, I mean, maybe not so dramatic, but pizza will be on our backs.
Yeah, just so dogs carrying that are tracking their record and what kind of meal they had, how much kilometers they had a day, and they attach that to dogs. So they didn't ask them if they can do it, I suppose.
I mean, we already have facts on what from dolphins and other bigger fishes. I think it's different than having artificial implants inside the fish, which you think even for the fish protection, for fish tracking, there's already facts to study animals, so it's not that far from that. It's just maybe different ethical concerns because now we don't have invasive materials.
That's a problem because we are coming to invasive things that when you put on we have watches today on us, but the long-term vision is that they put something in us, and that's a little bit of a problem. But I think that it's going to be solved. They will tell us that this is good for us, and we will carry it along, and fishes will do it probably before us. As I'm really provocative, I would like to ask one question to the audience. You as robotics, and my thought is that the biggest, people maybe would not agree, but the biggest turnover in robotics is mechatronics and materials. The end connections between these robots in the future. So let's say if we talk about these 5,000 fishes, not 5,000 fishes artificial in the sea. They have to communicate between them and be guided in direction along some point of direction that we want to send them. And this connection and this talk between them is very hard, especially underwater. I think I'm not an expert, of course you're going to say that. So this is some cases that needs a huge improvement, and mechatronics and materials. Who would agree and who would not agree with me? So nobody agrees. Or somebody agrees, please, at least one. No, so you think that software parts, artificial intelligence, or machine learning will be even greater distance in let's say 10 years than mechatronics and materials. This will be. Do you understand what I'm trying to say, or not?
When Massimo said about materials, he was referring to artificial fish, okay, not to robotics in general. Of course, that is one nice research area, but it's very difficult, and I know exactly why the people from the audience are quiet, because nobody wants to make statements on what is more important in robotics.
I can say because I'm not an expert, so.
Nobody is going. It's okay not to be an engineer. It's perfectly fine. But maybe, so in addition to, as you said, mechatronics of course is important. Software is definitely important. We are now in the times when not only that forms robotics, but we also have ethics. This is something that we touched upon a little bit. And then you have society, applications of these robotics. This is a nice combination of various disciplines that allow us to study multiple usages of robotics. I don't know if this answers your question, but the area is so complex that nobody would like to say, robotics, we have to do mechatronics. No, that is not true. There are so many social skills required in addition to engineering. Not to mention them.
Okay, thank you. Well, to wrap up this square table discussion, for me, the last question is coming from point of lead person running this strategic project in InnovaMare. We think, I think, and as a team on InnovaMare project, we think that placing innovation ecosystem regarding the underwater robotics and sensors in one place and developing that innovation ecosystem as a central place for collaboration and bringing together all the stakeholders involved in this element, and especially bringing to the table, because now they're not at the table, and these are the local and regional community as well as ministries who are the real impactor in a bigger scale than all of us could be, because they could bring huge assets from financing perspective, but as well as huge assets, putting some laws or some rules regarding this part that could have a huge impact on this sector. So we are bringing our innovation ecosystem, we are trying to bring these stakeholders to the table, that they understand what huge benefits not only the environment can have, but as well as the economical point of view. And innovation ecosystem shifting is the perception of that. The second thing is that we are trying to bring the community, from community perspective, science as well as private companies together to work on solutions that could today be problem solvers underneath the sea. But the main issue is not in our heads, in my head, is how this can happen. I can't maybe know the answer, and I'm going in that direction with the project. But when you are looking from your perspective as a scientist in each universities, and you are probably doing a lot of conferences, talking with a lot of your colleagues, from a position of science, scientific research institutions, what would be the most beneficial from a position of innovation system described as this? What would you say that needs to be done that it will work, that it will be possible? If you understand the question. Can you first give Italian? Did you hear the question? No? Okay. Do you hear me now? Do you hear me?
Maybe you should move in front of the mic.
Okay. Do you hear me now?
Yes.
Yes. Okay. The question is, what would you think that the key element would be for putting the innovation ecosystem in action from position of scientific research institutions? What would you think would be the best element? Is that in technology transfer? Is that bringing to table local and regional government, bringing to table private sector, or something like that? What would you think that would be the best element to raise innovation ecosystem?
Money.
I love it. Okay. Further, guys from the audience, do you have any idea?
At which level you think about? At the level of Croatian government, at the level of the European Commission, at the level of the world, at the level of local community?
At the level of innovation ecosystem. So we are having a central point to share regarding underwater robotics and sensors. And so we are saying to Europe and to the world, here is the central place for all of the people who are involved in this field, and we are working on social challenges as sea pollution is. What would you, from your perspective, what would your best benefit would be that we bring to the table? Would be the money, funding, as Mr. Gregory said? Would it be the ministry, regional, local government?
Also, the education. We have to start educating, that is, teaching about entrepreneurship and innovation management and entrepreneurship early on from the elementary school, probably. And teach people, students about creativity, human-centric design, innovation management from the early stages of the education, so that people get familiar with the whole concept of materializing, turning an idea into a product or a service. So we tend to train engineers and scientists, but not entrepreneurs. So I believe there is a need to integrate entrepreneurship education from early on in the schooling system.
Yeah, definitely. The part of our project is education models, where we will teach university scientists on innovation management, on spin-offs, and new business models. We want to, from your position, to understand how your knowledge can be transferred to the market with possible new business models, how spin-off works, how you develop a spin-off, what is the process, and how innovation management works, what is the process of innovation management. So this will be education models inside of InnovaMare project. But when you look from perspective of, let's say, some of your scientists, a long perspective of your work, is it to bring your work to a level of scientific ways, or do you want to bring it to the market? How many of you want to bring your knowledge to the market? Raise your hands. Yeah.
So researchers work within organizations. And I would be very, very surprised, not only surprised, but I would be very worried if every researcher, every scientist is trying to go to the market. No, researchers and scientists are usually best at doing research and science. However, they operate within organizations, and it's the organizations that should take structured forms of performing technology transfer. And that's the way to do it. Not to force researchers and scientists to spin off, to think about the marketing strategies, but the organizations in which they operate should take care of it.
I totally agree, and this that definitely needs to be improved in that level. That you said, please say.
Yeah, so you said, like, unfortunately, in Croatia, that's not the case. So you guys probably did all the work, as opposed to big universities like Stanford, which they have their own office. So whenever a student graduates, they right away check if that's transferable, and then the process begins. Probably you guys, I mean, I don't have experience in technology transfer, but you guys probably have to do everything by yourself, and it took you a lot of time. So it's not trivial to do.
Thank you, and this is basically the main topic digital innovation hub and innovation ecosystem in Chile. It will give all the knowledge necessary to the institutions so they can develop spin-offs and technology transfer and bring some of the solutions to the market. And I definitely agree with people who were talking about it, that institutions, scientific research institutions, should work mostly on the solutions that will be for 20, 30 years. You know, so you are thinking and researching something that should be usable in 20, 30 years, and some part of that could be already on the market, but maybe lower part than maybe 20 to 30% of all the research that you do on university. Guys, I would like to finish this square table discussion. Thank you very much for the Italian partners. I hope you understood our message regarding InnovaMare innovation ecosystem in Chile and with the branch in Italy as well. This is a very a project that could have a huge impact on cross-border cooperation because it's very important challenge for all countries. And I want to finish off with 2040, 5,000 artificial fishes in Adriatic Sea that are measuring in hourly basis all the data in Adriatic Sea and bringing these data to local and regional community and to our ministries so they can say fast what needs to be done that our environment is better. So thank you.
Thank you.
That's now lunch break, and at 2:30 we are back here with the tools.
So Massimo feedback was that he couldn't hear.